Check if everything should be live now. Let's see if this actually worked out. Yes, looks like this is running. Cool. Very nice. Let's post this also on Blue Sky. And yeah, now we are live actually. So welcome to today's stream. Today will be a lot of fun because we will actually do some really cool Gleam coding. So Gleam, well, you know, the language with Lucy, is actually a pretty cool language. And there is a very interesting thing out there called the MCP, the Model Context Protocol. This is actually how you make your AI agent, well, do whatever you want, like executing your code or modifying other stuff, fetching some resources, like, well, you can connect it to your database and let it ask your database for a table or some data or whatever. So obviously something you don't want to run against your production system, but well, let's figure this out. So what we want to do today is building our own MCP server. We will do this in Gleam because we will see Gleam is a very good language to do that. And we will actually see what we can do with the MCP, so with the Model Context Protocol. So let's directly jump into it. So first, let's start with the Gleam. Well, here's actually the Gleam page. If you haven't been into Gleam yet, that's a very good chance to do. You can just go to gleam.run and then check here, try Gleam. You will get some interactive environment where you can actually do some Gleam coding here. It is completely interactive. So if I just change this to my name, it will automatically evaluate here. So this is using some WebAssembly code running inside your browser. Also, if you like Gleam, feel free to sponsor it. Gleam is actually built by volunteers and they only depend on sponsoring. So if you have some money for the Gleam project, that would be awesome. And there's also documentation, other stuff around. But before we go too deep into that, let's quickly jump into what we want to build today. So here is the thing. So how does a model context protocol actually work? So let's quickly draw this down. So we have basically something, well, let's take a friendlier language. So we have something out here, which is basically our client. So actually it's not the client, it's actually an agent. So we have an AI agent. So this can be something like the Cursor IDE, or it can be something like GitHub Copilot, you know, some agent actually. Usually all these coding tools nowadays have their agentic mode, usually called the write mode or something like that. And you have this AI agent here. Let's also make the corners here, the edges here rounded. So you have actually this AI agent here. And this AI agent basically can only talk to an LLM. So somewhere here in the background, there is an LLM. This can be Claude, Sonnet, or this can be also ChatGPT if you want to use that one. Could also be some other one, you know, it could also be CodeStrawl from the Mistral team or whatever you like. So basically they are connected somehow. So whenever you enter something into the AI agent, some prompt, it will be sent to the LLM. The LLM will actually respond with some more or less meaningful thing. And it will actually do something. So what an agent does is it modifies your code or whatever. So here's the thing. Not all the things the AI agent wants to send or should send to the LLM is actually just given by a prompt. You know, you enter your prompt there and you send it to the LLM, or the AI agent is doing that. But what is about additional information? So what if the LLM decides, oh, I should probably have some additional information, like what is about, you know, let's say you have a Gleam project, and in your Gleam project, you want to know, or the LLM wants to know, if the dependencies are already there. So it probably wants to see the content of the gleam.toml file in the root of your project, because that's where the dependencies are defined. Or if you have a Node.js project, you want a package.json file, you know. The LLM doesn't know that if you don't provide it. So the LLM wants to ask for that. And so this is actually where the agent then has to provide this. Some of these things are actually part of the agents, which is nice, but not all of this is actually in the agent, or is built into the agent. So this is actually where the MCP comes in. So what the MCP does, well, actually the MCP starts actually with the MCP server. And the MCP server is then accessed by the AI agent through the MCP. So the model context protocol is used by the AI agent, which is the MCP client, to actually request some additional things from the MCP server. So this could be something like an MCP server that understands your Git project, or that knows something about I don't know, about your project, maybe a Node.js MCP or whatever. An interesting example of a newer model context protocol server that I really like and find fascinating is actually this new project here, Tidewave. So what Tidewave does is it actually it is a library that you put into your Phoenix or your Ruby on Rails project, and it exposes an MCP server right from your application. So this makes your Phoenix application actually an MCP server. And the language model can now connect to the running instance of your Phoenix application. Of course, you do this in development, not on production, obviously, but it can connect to the Phoenix application running there and interact with it. It can just ask the application, please execute this little piece of Elixir code here, or just fetch some, or use just your normal functions to query some data from your local database or something like that, or request the database schema or whatever, you know. It can do all kinds of things right from within the application. It's like a REPL, you know, it's like a REPL inside your application that is connected to your agent through the MCP. So this is a really interesting and really promising project. So if you haven't tried it out, feel free to give it a try. Really worth it. And these kind of MCP servers are basically the thing. So the MCP is a standard protocol that allows all types of AI agent to connect to all types of MCP servers, and MCP servers can provide all kind of data here. So if you want to learn more about the MCP, there's a Model Context Protocol IO page, and there's the specification on this page. There's user guide and SDKs here. You can go through it. This is a rough overview. You have the MCP client, which can be Cloud Desktop, or it can be an IDE or an editor like that. And then you have the MCP server, which is usually running on your local machine. And the MCP protocol is used by the MCP client to communicate to the server. And then the MCP server might have a local database, or maybe a file system, or it might request some data from a remote API. So the idea here is that the MCP server is like a I don't know, like a local proxy to some API, but of course the MCP protocol doesn't work like an API, so you need some kind of a translation here. But that's roughly the idea behind this. And yeah, if you want to get started with the MCP, you can go through it. There is also, I hope it's linked here somewhere. Maybe not. It's not. If you're looking for this, let's see. Yeah, there's a list of clients. Example clients was it. So if you go to the MCP or the Model Context Protocol IO/clients, you find actually a list of clients that support this. I'm pretty sure this is not a complete list, but it doesn't matter. So you have things here like Claude.ai, which actually supports the Model Context Protocol as well. Oh, I didn't know that actually. And you see here different things that they can support. So the most common ones are resources, prompts, and tools. We'll come into that in a second, but let's quickly go through that. Tools is probably the most common one. It's almost supported by everything, but also prompts and resources are quite interesting. So you see Claude.ai, Claude Code, which is a CLI tool by the Claude guys, which is pretty impressive. And also Claude Desktop, they support both the tools and the prompts. And the desktop and the web app also support the resources. Interesting that Claude Code doesn't do it. And you see more here. So we have the Copilot, MCP, I don't know what this is. Actually, one of the, I don't know, hippest things to work with nowadays is probably Cursor. I'm not a big fan of it, but because it's VS Code based, but still Cursor is quite popular, and interestingly, it just supports tools here. So the prompts and resources are not supported by it, which is sad because the other things are also very powerful. But yeah, that's how it works. You can go through this, see more of them here. Even Postman supports prompts and resources. I haven't tried Postman with AI support, but looks interesting. There's a Slack MCP client, whatever this does, and plenty more. The VS Code for GitHub Copilot, or the GitHub Copilot for VS Code, actually also supports tools. And that's quite interesting because VS Code is quite popular, and GitHub Copilot is, at least the last time I saw some stats on this, was actually one of the most popular choices for doing AI during coding. So I'm pretty sure that if this didn't change significantly, it might still be one of the most popular choices, and having some MCP support and also, of course, the agentic mode there available is probably not a bad thing, and might increase the usage here. The interesting thing is that also VS Code is the most popular IDE right now. And this is a quite interesting combination. So I'm really looking forward to see how much this will increase the usage of the agentic coding approach, as well as the agentic or the use of the Model Context Protocol for that. One of my own favorites here on this list is Z, which I use every now and then. And they also launched their agentic mode recently, which is pretty cool. Works quite well. And they also support MCP. Actually, they only support prompts due to this list, but that's not true. They also support tools. So it looks like the list is not fully up to date. So you see there's quite a lot of support. If you go through this list, many tools I haven't even heard of, but also many interesting ones. So this is actually how the whole thing works with the Model Context Protocol. And interestingly, you see it here already, the C# SDK has been released. So you see there's actually quite a list of SDKs. So we have a Python SDK and a TypeScript SDK. There's one for Java. But the interesting thing is there's also other SDKs that are not on this list. So if you look here into the Model Context Protocol GitHub organization here, you will see down here that there's also others. Like if we select Go, for example, no, Go, there's not one. But if we select Rust here, for example, there's a Rust SDK. This is not on the list, probably because it's still in development and not finalized yet. I think it's a very early version. Not sure if this 0.1 is, here. It is currently 0.1.5, so very, very early. But at least they are working on a Rust SDK as well. You see, it's based on Tokyo as an async runtime, and yeah, so they have at least also support. They are working on additional SDKs. So as I said, this stream is about doing this in Gleam. You see, there's no Gleam SDK. So what are we doing? So basically, the thing with Gleam is we can just select the TypeScript SDK because the TypeScript SDK works with Gleam as well. So how does this work? Let's go back to the drawing board. So basically, the concept is that you have, let's say, you have a Gleam application, and this Gleam application, you actually put into a deno runtime. So the whole trick here is that you compile your Gleam code to JavaScript. JavaScript is the first class compile target for Gleam, and you just compile your Gleam application to JavaScript and then use deno compile to wrap the whole thing into one single executable binary. So this is quite similar to what you get if you compile a Rust or Go application. You have just a single file as an outcome, and it's just executable and a native binary. Although it's of course not exactly like a Rust application. It comes with a garbage collector being baked in and a complete JavaScript runtime and some JavaScript code that the Gleam compiler created for you. But still, the experience is quite similar. And when JavaScript is a compile target, then obviously we can also use JavaScript SDKs and libraries. And this is quite cool because this widens actually the usage patterns of Gleam. For example, if you compare this to Elixir or Erlang, you're pretty much limited to the Erlang runtime. This is okay. The Erlang runtime is really good. But if you want a single executable binary, you can get this in Gleam just with the deno compile command and just wrap it this way. There's a lot of libraries in the TypeScript ecosystem or JavaScript ecosystem. This is not available on the Erlang platform. At least the ecosystem doesn't have the same size as the TypeScript ecosystem. That's definitely a big difference. So if you compile Gleam code to JavaScript code, this actually allows you to cover a lot of things and access a lot of libraries and access a huge ecosystem and gives you new possibilities that are not possible with just sticking on the Erlang platform, while you still can use the Erlang platform if you want to, So let's look into the TypeScript SDK actually. So we want to use a TypeScript SDK, we want to use deno as a runtime and to bundle everything as a single binary. And so how does the SDK work? I think this first example should give us a first idea. So we create an MCP server. Well, surprise, that's exactly what we want to do. Then we add here some tool or some resource. We saw this before here on the list of clients that we have different types like tools and resources. So this kind of maps to it. We will look into this in a second. And then what we do finally is we create a transport, which in this case is an stdio server transport, whatever this means. And then we connect the server through the transport and await it. So very straightforward. Let's look a little bit further. So we have some core concepts, a server, resource, tools, prompts. We can run the server. We have stdio transport that we saw already. We have streamable HTTP, which seems to be a little bit more things that you need to do. You actually have an express application here, and set up an endpoint here, and then implement a handler doing several things. Okay, this looks like a little bit more of boilerplate code around that. You can also have this without session management. Interesting. And well, looks like that's it. Okay, so yeah, here are some examples like yeah, the Echo example is probably not really interesting, but an SQLite Explorer. That's actually quite interesting example. So you basically, in this case, create a resource here, a resource schema /main, and you have a tool called query here. So basically you can fetch the schema from the database and return it somehow as a text. The LLM can then actually see your schema listed, all the tables and the columns and so on. And also the query tool here can be used then by the LLM to actually query something from the database. So looks like there is yeah, there's a query, and I don't know, maybe this SQL is actually the input that you give in. So the LLM can generate some SQL, pass it to the tool, and the tool will execute it and return the result in a stringified way here. Yeah, advanced usage, we won't go that far, but this is quite interesting, the low-level server. So what's that? It's interesting because that's probably what we want to use, because we want to use Gleam and not use all the high-level stuff from the TypeScript API. We just want to depend on the SDK to do the underlying protocol stuff, but not too much drive our code by it. So let's quickly look into that. We also create a server. Now it's not an MCP server, but a server. Get some configuration, okay. And then we add some request handlers for different schemas, okay? And then have a handler that we can just interact with. Like we can check what the params name is, and then have something that we return here. So this is more low-level implementation. If we look closer to the specification soon, you will see that this is quite what the specification says. You get a request and you get a return a response, basically. And this is what the handlers are doing here. And at the end, we are doing the same again. We are creating an stdio server transport, and we are connecting the server through the transport. So this is probably the example that we are looking for, the low-level server, to set up our own stuff in Gleam. And let's also quickly look into the spec. I promised this. We want to look into the spec as well. So the core concepts. Let's yeah, we also already saw there's a client and there's an MCP server. So now the interesting part is that there is this transport layer in between. So there are two types of transport layers in between the client and the server. And the transport layers that we have are HTTP and stdio. stdio is basically the same as the language server protocol works. So if your VS Code or Cursor or whatever provides you some IDE functionality, like like when you press the dot in TypeScript, you get some auto-completion provided or something like that. This is typically provided by a language server, so some tool that is running in the background. It's started by VS Code, it's running in the background, and VS Code is actually communicating to it. And all the other editors that are supporting this are basically doing the same. They are a client for the language server protocol. The LSP and the MCP is designed very similar to the LSP. So it also uses the same transport layers. And the one that is provided by the language server protocol, and it's also used by MCP, is the stdio. So basically, the client starts a process in the background with your MCP server, and it uses the std_in to send actually requests to the server, and it awaits the responses from the server on the std_out of this process. So it's just a normal communication between two processes, if you want it like that, where one is a parent and one is a child. And this simple protocol allows you to work without any ports to be acquired, no security issues that you open up by having some application running in the background, listening for HTTP on your laptop, and makes it quite simple to set up. So this is an interesting approach, but it also comes with some limitations, of course. For example, you cannot offer this remotely, and you cannot run this centrally. You know, if you want a central daemon, like let's say Docker, for example, comes with a central daemon that orchestrates all your containers, and then you have a CLI or whatever client who connects to it via HTTP. This is very crucial in Docker because the central daemon knows actually the state about the whole system or the whole environment, which containers are currently running and not. You cannot have this with something like the language server protocol. So having this in a stateless fashion while running multiple instances at the same time might become a problem, at least when you want to store state. And this is where a central daemon, for example, with the HTTP protocol might be much better. And so the remote access is the other case. So beside the std_out, we also have the, I don't know if it's mentioned here, we also have the HTTP with SSE support. There's also now a newer version with the streamable HTTP. We don't go too much into details here, but we have the std_in and then we have the HTTP with server send events. So the way this works is the client actually creates an HTTP request to a resource, to an endpoint actually, that responds with server send events. This is a standard from the web APIs supported by browsers, for example, that the connection doesn't close immediately, but instead the server can send events whenever it likes through this connection. And there is a standard how these events should look like. And this API is used here, similar to the std_out and the stdio transport. So the server can use this open connection that is opened by the client to send the responses or notifications it wants to send it to the client. And the first thing it returns is an event that is specified in a specific way that contains a URL to which the server can do HTTP post requests to send requests to the server. So this takes over the role of std_in in the other transport. So a typical thing would be that this URL here that is returned in the first event contains an identifier for the session. And so the session, so every request that comes to this particular session ID, the responses might always go through the same server send event connection that is kept open. So this way you have have two streams, one coming in through a session identifier and HTTP post request, and you have the server send event connection that is also associated with the same session ID to which you send out the responses. So you see the HTTP protocol isn't really used here. Instead, it is just a transport layer, as the name said. It is just the way how data is transported. But in both cases, and you see it here, all transports use JSON RPC 2.0. And this is exactly the point. So the protocol, like the LSP protocol as well, the MCP is a JSON RPC protocol. So you send JSON RPC messages back and forth. And you just use stdio or HTTP with server send events as a transport layer. You don't make any use of functionality of the protocols itself. They are just for transporting your data. And that's basically how the MCP works. Now let's quickly look into the resources here. Yeah, let's start with the resources. So the MCP also defines these different types of tools, or actually, I don't know, of resources is also the wrong name. It defines different types of things that, capabilities, I think is the right name here. And what you see here is a resource is identified by URIs, and you have a protocol, you have a host, you have a path, and then you have different resource types, like text resources, binary resources, and so on and so on. And so what the server provides is it provides a resource list endpoint, or if a server offers resources, it can provide a resource list endpoint, and then each resource is shown as this JSON here. There is this template. You can also have a resource read endpoint, which is called with the URI of the resource. So we saw it here on the bottom, on the top. You get a list of resources where each has a URI, a name, a description, a MIME type. And now you can read one explicitly, and it might have a text or a blob, which is base64 encoded as a content. So you could, for example, say, okay, I want to provide files from within my project as resources. And so you could list all the files from the project, or maybe from a specific directory. I don't know if there's some filtering capability. Doesn't say something about that. So you could list everything from a specific, from your project, for example, or everything from a GitHub repository, or whatever, you know, can be all kinds of things. And then you get something like this back. And you can also do updates on resources, which is quite interesting. So you can change them as well. You can send some content to them. So this is quite interesting if you think about having a file, which could also be on a remote server, for example. But you can actually tell your LLM to generate a new image and then send the new version of the image to, or update this resource with the newly generated image or something like that. Not sure if the LLM will understand how to do that, but at least it could. So resources are quite interesting. I didn't look too much into them because they are also not very much supported by most of the clients, especially when it comes to coding. But let's also look into prompts. So prompts are also not that much supported, but they are at least simpler to implement. So prompts are basically defined like this. You have a name, you have a description, and then you have arguments to the prompt. Arguments because prompts can also be dynamic, so you can actually Yeah, think of it like a template. The prompt can be a template, and you can pass in some arguments that are used to or that are used within the template to generate a prompt from that. And there are basically two commands or two capabilities actually for dealing with prompts. The first one is for discovering them. You have a prompts list endpoint in your MCP server. It returns obviously a list of prompts. And for example, the analyze code prompt, it has a description, and you can provide a language argument here, and this is required. So if the LLM calls this tool, prompts list, it will get this prompt provided, and if it wants to use the analyze code prompt, then it will have to provide the language argument and can say, okay, I want to analyze this code, it's Python or whatever, you know. And the same goes for the usage. So you can use prompts get, which basically means you can get a specific prompt. So in this case, the request is also quite straightforward. We have the endpoint that we call. We have then the params provided. So actually, which prompt do we want to get? And we provide the arguments. So in this case, language Python to analyze this. And the response might then look like this. We have then the role, which is typically the user or something like that. And you provide some messages as a response with some content, type text. Please analyze the following Python code. Which is quite interesting because you always analyze the same Python code. But it's just an example, of course. So you could provide some more advanced stuff here. For example, you could also provide the URL of a resource here that you might have requested before. And then if the MCP understands the URL here of the resource, it could use this to fetch the Python code from that resource internally and use that, for example. So you could list all the resources, see a specific resource you are interested in, pass the URI here, and do something if you want to implement something like this. There's also dynamic prompts. So you can change this. So there can be new prompts over time. And yeah, there's also an interesting example with a multi-step workflow. And an example implementation here, which is a little bit bigger. Of course, it's done in TypeScript. There's a Python example as well. Should be pretty similar. But this is a TypeScript one using the request handler. So the low-level server that we have seen before that we want to use also, by the way. And yeah, some best practices, UI integration. That's all the time. And then finally, we have the last one, which is tools. The last one, which is interesting. So for tools, the tools are quite interesting because they are not just providing some prompt that you can call or that an LLM can actually, or that you return to the LLM so it gets some instructions, for example. The tool is quite interesting because you can do some more advanced things here because a tool can do all kind of things, you know. You could make every command line tool that you have on your laptop a tool in an MCP. So you could just call git commit through a tool if you make a git commit tool, you know. That's quite powerful, of course. And yeah, looks like they only provide examples here, but the basic concept is very similar to a prompt. You can execute a command, for example. In this case, you have a tool called execute command. There should also be a list. Oh, there should also be a list for that. Doesn't matter. So you can, in this case, we have an execute command tool, and it can run a shell command, surprise. And it also has some properties. In this case, you provide the command itself as a string, and you can provide some additional args here, some arguments as an array here. And this way you can, a command can be executed. This is a very dynamic thing. You know, you could provide here git as a command, and you could provide here commit -m and then some message here, and then execute git commit here through this tool, or similar things. And you can also wrap external APIs here, obviously. So you can just say, okay, I want to create a GitHub issue. If your MCP server provides a tool to create GitHub issues, and then you can have an input schema, which is of type object with the properties title, body, and some labels. And this might create an HTTP request in the background to the GitHub API to create actually an issue with this data as an input. So pretty straightforward. You can do also queries or whatever you want through this. We have seen the database query example previously already. So all kind of things you can do here. And yeah, there's, as I said, there's a tool discovery and updates functionality. So clients can list available tools at any time. Server can notify clients when tool change using the notification tools list changed. So this means that the client is always able to fetch the list of available tools from an MCP server, and it can, and if the tools change in a running MCP instance, then the server can also notify the client here to update the tools. So this can be pretty dynamic. So in theory, just thinking here, you could ask your LLM to write a little script and create a new tool from that script. Let's say you have an MCP server that looks into a specific directory and uses every Python script from within this directory as a command or as a tool, and it can execute it, let's say through Python, and then provide the name of the script. You could ask an LLM to generate a new Python script and write it into that file, and then it could use actually, or it could automatically be added as a new tool, and then the LLM could use the code that it has just written and executed to modify things, you know. So this could be an example of where you can actually go quite crazy, and vibe coding might become even dangerous at some point in time when you go too far on that. So also some example code here, tool annotation. Let's ignore this for the moment. And anything else here? Yeah, let's ignore this part. Yeah, testing. Of course, we want to test as well. There are other like sampling and routes and transports we have seen already. Sampling and routes we will ignore for the moment. I think resources, prompts, and tools are currently the most important things in MCP. Tools is probably the most supported one, and prompts and resources are also quite popular. For this stream, we will start with prompts, mainly because that's the easier one. I think it is time to look also into writing the code and doing something. So let's quickly jump over. This, by the way, is Z. As I promised, it has also now an AI agent. built in. We will see that one later. Or maybe we will see this one later. Let's see. But this is not a vibe coding stream. This is actually a real coding stream. So let's quickly walk through the project here. So this is a Gleam project. We have here a Gleam TOML. It doesn't have much more than the standard lib as a dependency right now, but it is targeting JavaScript. As I said, Gleam can run inside deno, and we can use deno compile. So we have set the JavaScript runtime here for the Gleam project to deno. And because deno has all this security sandboxing, we also need to allow access to the Gleam TOML and the tests, at least for running. And I can also show you why this is necessary. So let's say we run Gleam test. So the one test that we have is actually executed here, and it runs. And if we don't provide these permissions here, this will just not work because deno will restrict the access. So this is actually necessary for executing the tests. And just saying that, because we set this to JavaScript and to the runtime deno, this also means that if you run Gleam tests, or if you run Gleam run to run your application, you actually run this within deno. So the Gleam command will compile the code to JavaScript, the Gleam code, and execute it inside of the deno runtime already. So you get execution not somewhere in some virtual environment, and it's really inside the deno runtime here. I've currently the 2.3.1 installed and the Gleam 1.10. So this is both the latest version, and it should just work. So let's leave the project alone. How does it work in general with deno? So here we have, as I said, we have the this is a Gleam project. So cozycoder.gleam is on our main Gleam file. There's a main function, and currently it's just printing hello from cozycoder, which is, well, not very much, but at least it works. So this is actually what you have seen when I ran Gleam run here. Then you see hello from cozycoder, because that's what Gleam run does, executing the main function. There's also a test. Let's ignore the test for the moment, or well, for the stream. This is not about writing the tests in Gleam. This is about making some LSP stuff work. As I said, we use deno, so we also have to use deno for dependencies to other JavaScript code. So while Gleam libraries are added as dependencies here in the Gleam TOML, the deno.json contains the dependencies for deno, and this includes also npm. So I added here already the Model Context Protocol SDK. It is prefixed here with npm, and this is actually how deno declares this and ensures that this is fetched and provided at runtime. And the last thing that we need to make all of this work, there's also a deno log file and a manifest TOML. This is for Gleam, this is for deno. They are like a package JSON log or something like that. You have this in all languages and package managers, these wonderful log files. And but the most important one here is now the main TS. So what this little TypeScript file does is it imports the main function from build dev JavaScript cozycoder.mjs. So this is actually the JavaScript file that Gleam creates when compiling our code, our Gleam code here. And it compiles it to this file here, and the main function, this one here, compiled to JavaScript, will be as a main function in this file. We can also go into that file and see, yeah, there's really export function main, and it does some return IO print line. Actually, it's very similar to what we have seen right now. Just that that $IO is something that we import here from Gleam IO MJS. But beside that, so it is basically translating this, and we are just executing this. So this is necessary to make the whole thing work. With deno. And so let's, or with deno compile. Because running it with deno, we have seen Gleam run does it. But if we want to run this with deno compile, you see it's very straightforward. Deno compile main TS. We provide this main TS file, and this will package everything together. So it printed out a lot of things here. Let's quickly look at what is all going in here. So you can see that it compiled main TS to the file cozy coda, and it embedded a lot of files like the Model Context Protocol SDK, some other dependencies here. You see there's quite some dependencies, probably all coming from NPM. Then there's this build, dev JavaScript cozy coda MJS, and the Gleam standard lib. So a few things from the Gleam standard lib, like int and floats and so on, are compiled in here as well. There's a Gleam MJS and so on, a prelude MJS, and of course our main TS file. So all of this JavaScript and TypeScript code is actually bundled together with the deno runtime. So in total, this is 6 MB, almost 7 MB of files, and all of this is bundled. So as so let's quickly look. The output said there's a cozy coda file now, and there is. So we see it here. It is 87 MB big. So it's not as small and tiny as a Rust program, a Rust Hello World would look like, or also a Go Hello World would probably be a smaller executable. Nevertheless, this of course comes from the deno overhead, because we have a full JavaScript runtime and bundled with our application here. But still 87 MB is, it is not small, but it's also not very huge. So I have seen much bigger applications, and this will, and usually such a size is, for a tool that you download locally, is not really a big problem. So it is a single binary and it's executable, so we can simply run it, and it prints hello from cozy coda, so exactly the same as before. So everything works. So this is basically our project setup. So now let's make use of it. As I said, we have the Model Context Protocol SDK already installed here. That's the one from the official TypeScript SDK that we have seen before. And we can now use that one. And the interesting question is, how do we do that? So the first thing that we do is let's have another look into the SDK documentation here. So we want to use the low-level server actually. So what we need to do is first we need to create this server. Well, this seems to be straightforward. And the second thing that we need to do is we need to call, we need to create a transport, and we want to use the stdio transport here as well. So basically the MCP client will start our application as a background process and connect through std in and std out to it. And then we start this, or we connect the server to the transport. So that should be it, isn't it? So the way we do this in Gleam is quite simple, because Gleam provides form function interface functionality here. So let's write some some stuff here. Of course, this is not how it looks like. AI is not that smart. So the way this works is like this. And of course, the function will not be named like that. So basically what you do is you write a function. In our case, we want to create a server. So let's go back to the documentation. We want to create a server first, and we want then to connect the server to the transport. So we basically want two functions, one for creating the server and one for connecting it to the transport. So the first one is we need a function to create the server. So let's do that. Yeah, interestingly, that is not fully what we want to do. So we want to, yeah, we don't want to create it like that. What we also want is we want to return a server from it. So let's also do that. So we have a function that returns a server and that we call to create a server, and it returns a server. And that function is defined in JavaScript. It's an external function. There will be a file cozycoda ffi.mjs. That's how you usually call these JavaScript files to provide foreign function interfaces. And we need to tell the Gleam compiler what's the name of the function. So the name of the function will be create server, because in JavaScript we write camel cases. So now we have a type defined that the function should return, and we can now define the cozy coda ffi.mjs file here. So this is a standard JavaScript file, and we can now define a function, create server. Of course, it should not just return a new server. Let's go back to our example here. What we really want to do is we want to import the server here from the Model Context Protocol SDK. And we want to return that server. No, not that one. This one. And we don't want to create a constant here. We want to just return the server. So let's do that one. So now we have the create server function. We return a new server, which is a server from the Model Context Protocol SDK. And it has a name and a version and actually no real capabilities. That's exactly what we are starting with. So let's continue there. So we have now created the server. And the second thing we want to do is, and of course, we also need to use that function. So let server. So now we create a server. And what is the problem here? Yeah, that's okay. We will fix that in a second. So the second thing we want to do is we want to start, or no, we want to connect these servers. So let's create another function, which is not actually start, but let's say we want to MCP connect through STD.io protocol. And we provide the server here, it returns nil, that's all fine. And we call this not start server, we call this MCP connect STD.io. Correct. I think we should also call that one here MCP become that, and then we can actually connect to the server, and that's it. So basically this is how it should work. So we have a create server function, so we can also create the second function, which would be the MCP connect stdio. By the way, before we forget this, we also prefix this with MCP. So we provide a server. This is JavaScript. And we don't return anything. Let's quickly look for the document or the example here. So we need another import. For the stdio server transport. And then, well, we just copy that one. Here we go. It should, of course, be an async function. And that should be everything. So we now should have a function that we call to create and want to connect the stdio. And we have the server here, imported everything. So let's see if this runs. The interesting question is, how do we actually test this? And there is an interesting way to do that. So usually you don't want to integrate this with your LLM directly and stuff like that. You just want to see that the MCP server is doing what it should. And an easy way to try this out is the MCP inspector. So the MCP inspector is also in the official Model Context Protocol repositories. And the MCP inspector is a web application, JavaScript based. And it runs on Node.js, so you can just run it locally. And this is basically how you run it. You just call it from npx, so you don't have to install it actually, and you provide the command to start your server as an argument to it. And it will basically start your Model Context Protocol server for you, and then provide you a user interface where you can interact with it. So let's do that. And actually, I have already done that and prepared that. So I have so I use Mies for running the for managing the environment. So it installed Gleam and Deno, and I have defined a dev task actually, which executes this command here. So it does npx with the MCP inspector, and then passes Gleam run to it, because Gleam run is actually our Model Context Protocol server. So we can simply use that one. and this is just mise run dev. And we see now the proxy server listening on port 6277. And there is the MCP inspector running here. So let's see what's going on here. So this is the user interface. Looking at the documentation, seems to have a light mode as well. Inspector version 0.12. Here we are connected through the stdio transport. There's an SSE transport as well. This is the HTTP based one. There's also the streamable HTTP that is currently in development. The command is Gleam. The arguments is run. So yeah, that's exactly what we have seen. So it's currently disconnected. So we can connect and we get some we get some error messages. So the error is uncaught syntax error. The requested module cozycoder FFIMJS does not provide an export named MCP connect stdio. Okay, interesting. Why doesn't it provide this? And here I see already the problem. So what it doesn't do is exporting the functions. So this is of course required. Declaring the functions is one thing, exporting them is another thing. So we definitely need to do this as well. The good thing is we can just press connect again. Let's clear it. And it will just try to start the server again. So this is actually quite cool. On the stdio transport, the client will just start the command, run it in the background, and it is for the inspector. You can just restart it and it will just connect again. When we run restart, you see also there's an error output from the MCP server, which is compiled and running. So this is actually not an error. This is just the normal output of Gleam run, which compiles the code and so on. So normally when you ship this to production, this information will not be there. So let's clear this. And we have now an MCP server. The MCP server declared some prompts, but let's quickly look into that. So we have an initialize and, well, an initialize call so this is a request from the client, method initialize, and the response is capabilities nothing, just an empty list of prompts. And the server info is example server in version 1.0.0. There are no resources, no tools. We can also ping this server. So let's just do that. We have a ping request and the response is successful and empty. I hope this is the correct behavior. And that's it. So we see we have an MCP server now. It is running and it is written in Gleam. To be honest, right now it looks like just a little bit of Gleam code that is delegating things to to JavaScript, and actually JavaScript is doing most of the work. So let's remove some of the stuff from this JavaScript code here to make it more tiny. So the very first thing is actually, of course, we want to provide this configuration here. Actually, not the server, this needs to be provided here, but we want to provide this configuration here as an argument here. We don't want this to be provided from here. Actually, not the full one. If we look here, is there some? No, of course not. Yeah, so we want to actually provide these options here through here. So let's introduce Let's introduce some options argument. The options here. Of course, this will not work, obviously. So if we go back to the MCP server, it doesn't restart automatically. That's good. This will not work because our MCP create server function here in Gleam doesn't have options. So let's also define server options. So not really like that, but type server options, and this type will the name type string and the version type string in this case. So let's provide also the options as the let's also provide the options as here. The code doesn't compile anymore, which is totally right. And we provide now the name and this stuff here. Nevertheless, the version should be 0.1, 0, and the server should be Cozy Coder instead. So now we have the server options passed in. So let options this replace this, and now we can try this again. So now let's just restart it. And it compiled again, it worked again, and we have an initialize request. And this initialize request, this new one, the fourth one, is actually after the restart. And we see still the capabilities are nothing, but the server info has changed now. It's now Cozy Coder, and we have the version being correct. So you see, you can just restart from here and it will just work. So now we have simplified this a little bit. Let's do the same with the capabilities and the prompts. But first, let's see what the what we can find about the server. The interesting question is, where do I find documentation about it? The TypeScript SD. No, come on, that's where we are coming from. Okay, looks like this is not. Server options. This looks like capabilities and instructions. Both are optional. Instructions Okay, how to use the server and its features. Okay, interesting. And the server capabilities, this type is defined here. Capability schema. Wait. Thing also can go is actually the specification. So let's have a look into. So the most of the MCP clients are currently supporting the November 2024 version of the specification. So let's see the server features from that specification. We have prompts. So so we have requests and responses and notifications. That's fine. We have server features. Yeah. The life cycle. What is the life cycle? So initialization, that's already what we have seen. The initialize request, the initialize response. The interesting question is, so the initialize request comes in and provides us params. So this contains client infos as well as parameters, sampling, and so it basically tells what it can do, what protocol version and what it can do. And the server must respond with the protocol version and the capabilities and server info. Let's have a quick look. So we have seen the server info, and this actually reminds me of renaming this, because this is then the server info, and we should also rename it here. Here. By the way, that's a nice feature in Z that I really like. I rename it here, and and the AI auto completion feature here automatically provides me to rename it here as well. So it doesn't just auto complete; it actually changes more code than this. That still has a problem here. Unknown type server info. Right. It is there. Okay. The second thing is the capability. So the other type of server options is um, that's we also want is we want to type capability and we want to pass the capability. That's not nice idea. It's the capabilities is actually capability. These names starts it what is the thing it should provide? A list. Yeah, so it should provide prompts where okay, so it provides the capabilities and always puts true. And that's it. It only provides can do reads, but server not. Now the client can have these. Ability to provide file system routes. Ah, okay. Ah, interesting. I didn't know that actually. So the client can provide file system routes, whatever this means, and sampling, while the server can provide these kind of things. Okay, interesting. So then we just need to set them all to true. And I don't know if this is done automatically. Let's quickly look into the SDK. It is prompts, it is an object. If the whether this server supports issuing notifications for changes. Hmm. Okay, let's try. So let's try to provide. Yeah, what do we provide there? We provide a server capability. The server capability is not a prompt, it is interesting thing. Let's say server capability prompt is a map to. This is not how you define this in Gleam. There's an unknown type. Did you mean yes? Okay. In Gleam, let's see. Guess this is not. It is some type. Standard filter. This. Okay. So we need to import this one. Gleam map. What type of standard lib do we have right now? Okay. Um, yeah. So what happened to the a dictionary of keys and values? Ah, great. That's easy. Then I see where we are going. Okay. This is like Python. So there is no map. It is dict. String to boot. So now we have a dict. And we can provide its capability and abilities. Yeah. So dict new. Not don't want dict new. We want dict. And we can provide it is prompts the want to provide. Let's take a look to the example. For example, we have the list chain. Yeah, this is the standard. Capability. Let's say we want to start with a hello world. So very fluent in Gleam yet, so Gleam. Uh, yes, true. Code that compiles. And I hope it will provide capabilities. So the code looks now much more, much smaller on the JavaScript side. Let's also have a look on the Gleam side, where the code now looks, well, still quite small, but better. So also let's introduce here, hello. This becomes the true. Yeah, this is actually the smart capability of that you can just edit it like that. So let's give the inspector another try. So what happens if we restart it? And now we have, I was just confused because I saw nothing is in it, but this is the fourth request, the initialize. The new one is the fifth one. So let's look into that. And oh no, the capabilities are empty. Damn. Now, why is the capabilities empty? That's, wait, I have an idea. And this is because, we just passed in the prompts, but removed the capabilities here. So, looks like the model is more than this. So we have the capabilities, but the capabilities also needs type capability. Doesn't have prompts, but the capabilities. The capabilities is not a dictionary, it is server capability, which hmm, could, in theory, rename this to prompt. So we could have more of that. And we can change this here to prompts. This here to capabilities. This doesn't work. Ability server capability. I think the options idea was a good one. And the options is and this is then the capabilities. This is the server capabilities, but it has prompts. This is the capability. So pass in the server options, which is the info and the capabilities. And capabilities. Capabilities is now no longer so. This, we change this as well. This is now options. Nice. Let's also see here. No, this. Capabilities, but that's not true. Yet. Do it like that. Let's see. Go to the inspector, restart. Oh, didn't work. That's that. Mm, enable. Capability. That's this should work. Okay. Still don't have capabilities. Come on. And we don't have capabilities because what? Because we pass in the capabilities here. And once again, we don't have them here. So let's also, let's see if this works then. Okay. Let's see if this works actually. The new one ring? Yay! Here we go. Awesome. we have now prompts, which is not exactly what I expected. um, prompts, found. That makes sense. Okay, some response came back, but we still have to figure out what. Good, that's at least a starting point. So the next thing is we have now provided capabilities. We now want to provide the right capabilities. So first of all, it looks like the dictionary is not going to work here. So we probably have to introduce a new type. Type server capability. Doesn't that. Interesting question is, what can I pass to it? Wait a second. I remember there is also some Gleam JavaScript. Let's see what this is doing. Gleam JavaScript interrupt is providing prompts. Looking for. Interesting question. Can I just provide this? So if I make this stuff, but it's not a So bullshit. I guess I have to this is now I know what to do. This is the third thing. Then this. Capabilities, thoughts. Is the can be this this that speed. Nice try. This should capabilities prompts map. Let's see if this works. This we get the prompts mapped. Fine, now we have it. Okay, now we have a little function that creates the capabilities. Let's make this also constant. Let's see what our inspector says. Something we know. Let's doesn't log the error here. This is really how I want logs being shown. Type error. That is not a function. Okay. Let's give it another try. This one we saw just a second ago. Array. That's what we want. JavaScript. See if this helps. Doesn't help if we don't run this, obviously. This is actually not. Yeah, let's see again. Is your MCP server running? Well, I was hoping. Let's find the answer. So it runs and it doesn't complain. What's going on? What's wrong here? Good. And stop the extractor. Start the application. That's the application. But it doesn't connect. Um, it doesn't tell us anything where it's going wrong. Wonderful. Okay, that's not very helpful. Let's see what this is going wrong. No idea how to fix this right now. Yeah, nice sweater, by the way. Yeah, Alex, I totally agree. Gleam is actually a nice language as long as it works like every language. um, but let's quickly jump into that. Console log capabilities. Let's see what this is doing. I think this too. That's better. Let's see. Maybe it doesn't copy the FFI over. Doesn't do anything. That's weird. Is your MCP running? Yes, it is. stdio Gleam. Then why it's not starting? Oh wait, I get something. Syntax error. Unexpected token C. Creating. Jason. The prompts. Not valid JSON. But at least the capabilities work. At least I hope so. Okay, let's check again. The server options, it has in-person capabilities. This works. The server capabilities have prompts. And the prompts should have an array. Server capabilities. But the server capability is not working as expected. Idea. So let's say we put in strings here. Because in the end we just want to provide the capability as strings. See if this works. Didn't expect this to work, but at least I expected this to have a different output, but it doesn't. JSON string defined prompts. This is not valid JSON. Stupid. Looks like I'm missing something here. The question is just what? So let's quickly go through it once again. What do we want to pass here? We want to pass a list of capabilities. But link this to a JavaScript array. So this is what we are doing to create an array. Case of strings that we want to pass in there. Just do it like that. Let's simplify the code. This anymore. Give it another try. Let's see. Connect. So prompts hello world. Capabilities undefined. This makes sense. because yeah, just sign true. That's not exactly what we want. We don't want a list of prompts. We want a list. No, we want an object. Tools. Incoming list. Capabilities. Should be an object. Of course it should. And then we iterate through the prompts. And that capabilities to this. We don't do the map, we do the body. We don't have a return. This one, just this one. Yeah, that looks a lot better. So now capability should different. This becomes this capabilities. Again, should call them prompts. This looks good. Looks still the same, so this makes a lot of sense. Let's run the proxy once again. And let's give the inspector another try. It's connected again. Wow, cool. So now we have the initialize and we have a hello world prompt. Woo! This is exactly how it should be. So it looks like, as we have seen, there's still something going wrong. Well, let's fix this another time. um, these later. First, we have this code working now, which is pretty nice. And abilities, server name, and we can start implementing this. So we could click now the list prompts, and of course we don't get any prompts. This is still the case because we didn't create any prompts. So what would be next is, and this doesn't happen today, to be honest. So the next steps, what comes next? The next step would be that we add a list prompts request handler, actually. So the list prompts request schema is, well, defining the schema for this. So we set a handler for this list prompts, and we would also set a handler for the get prompts or get prompt. And we would then actually work with that. So we would have the list prompts handler, and the list prompts handler would return then some prompt. What's like this, it's just some random stuff. We will probably implement this as a Gleam type and then return it as some JavaScript object. Let's see how to do this best. And pretty much the same here for the request handler. We would do the same here and have then the hello world prompt being checked and return something like hello world and then do something like that. So this would be the next step to get this working and have then the whole setup working like this. What I really wonder is if this prompts here at the beginning is really the same as the list of prompts that we could return. Maybe we just have to return here the list prompts request schema, and maybe this is even added automatically by this. So maybe we have done all the stuff now without any reason, and this will be automatically set. We will figure this out later. But that's basically it. So this is how you write some Gleam code and make it an MCP server. So we have really just the basics of an MCP server here. It's not ready yet. It's not working fully, but it's a starting point. It works. It connects. It can be connected from the inspector, that we have seen, and this can now be the starting point for a next iteration to finally get some prompts being returned here in a proper way. So then stay tuned for the next time, and we will continue from there. Thanks for joining. Have a great night as well. And yeah, thanks for the stream. I also love that you actually joined the stream, and I hope you enjoyed it. We will continue with this wonderful Gleam stuff, actually. It was a lot of fun.